So welcome to all in this online classes platform. Today's topic is double integrals. Now definite integral a to b fx dx is physically the area under a curve y equal to fx, the x-axis and the two ordinates x equal to a and x equal to b, and this is represented by this figure. So it is defined as the limit of the sum of these small areas fx1, del of x1, fx2, del of x2, and so on, when n tends to infinity and each of the length delta x1, delta x2, and delta xn tends to 0. And here delta x1, x2 are the n sum divisions into which the range of integration has been divided. Now the double integral is the counterpart of this integral, this definition of integral in two dimensions. If fxy be a single valued function and bounded function of two independent variables x and y defined in a closed region A in xy plane, and let A be the total area A be divided into n elementary parts, del A1, A2, An in this way, and let xr, yr be any point inside the rth elementary area, then we consider the sum fx1, y1 del x1 plus fx2, y2 del x2 and so on, and this is sigma r equal to 1 to n fx r yr del of ar. Then the limit of the sum, if it is exists as n tends to infinity, is defined as the double integral of the function over the region A, and it is expressed as double integral over area A fxy d of A. Now, thus we have double integral fxy dA is limit n tends to infinity del of AR sigma r equal to 1 to n fxr yr del of AR. So we can see here that the double integrals are the limited or of limited use if they are evaluated as a sum limit of a sum. However, they are very useful for the physical problems when they are evaluated by treating successive single integrals. So first we see how we can evaluate these double integrals. Now, first case, when the region R is bounded by two continuous curves y equal to psi x and phi x, and the two lines x equal to a and x equal to b. Then in such a case, the integral is first performed with respect to y, keeping x as constant, and then the resulting integral is integrated within the limit x equal to a and x equal to b. Here we can see that we have the limit of y in terms of x. The limit of x is constant. So first we integrate with respect to x partially. I am telling partially. Partially means when we are integrating with respect to one variable, then other variable is treated as constant. So here the value limit of y is given as a function of x. So first we integrate with respect to y partially. In that case, we keep x constant, and then we solve the integral and put the limit of y in terms of x. Then we get the value of integral having only variable x. Next, we integrate with respect to x and put the limit of x from x equal to a to x equal to b. So in this type of case, the integration is first performed with respect to y, keeping x as constant, and then resulting integral is integrated within the limit x equal to a and x equal to b. And in this case, we have these two curves, y equal to phi x and y equal to psi x, and we have to integrate in between x equal to a and x equal to b. It means we have to vary the limit from x equal to a to x equal to b. So we consider a elementary strip parallel to y-axis, and this strip will vary from left to right to calculate the area of whole region. Similarly, if we have this case when x is function of y, and it means the region is bounded by two continuous curves, x equal to phi y and x equal to psi y, and the two lines y equal to a and y equal to b. In this case, we have this type of picture. This is x equal to phi y and this is x equal to psi y. And we have to obtain the area bounded by ABCD. So in this case, y is varying from y equal to a to y equal to b as a constant limit, and x is varies from x equal to phi y to x equal to psi y. So in this case, we consider the elementary strip parallel to x-axis in this way, and we vary this elementary strip from y equal to a to y equal to b in horizontal as a horizontal movement. So in such case, integration is first performed with respect to x, keeping y as constant, and then resulting integral is integrated between two limits y equal to a and y equal to b. So mathematically, we can write it as integral over r fxy dx dy. If we are taking two-dimensional case, so in that case, the elementary area dA will be dx into dy, and here the limit will be integral a to y equal to a to b, and x varies from x equal to theta y to x equal to psi y fxy dx dy. So in this case, first we integrate with respect to x, then with respect to y. Now when both the pair of limits are constant, the reason of integration is the rectangle given by this one. Suppose we have y equal to a, x equal to a to x equal to b, and y equal to b to y equal to a, and so on. So in that case, we can consider strip parallel to x axis और strip parallel to y axis. यानी कि इस केस में हम किसी भी वेरिएबल के रिस्पेक्ट में पहले इंटीग्रेट कर सकते हैं. जब x के रेस्पेक्ट में इंटीग्रेट करेंगे, देन वी कीप y एज कांस्टेंट, और फिर उसके बाद y के रेस्पेक्ट में इंटीग्रेट करेंगे. So we can see here that while calculating double integral, in either case, we proceed outward from the innermost integration. And this concept can be generalized to repeated integrals with 3 or more variables. यानी कि इस केस में हम अंदर से बाहर की तरफ मूव करेंगे. जैसे dy dx लिखा हुआ है, तो it means we will first integrate with respect to y, then with respect to x. और यही कॉन्सेप्ट 3 या 3 से ज़्यादा वेरिएबल्स के लिए भी हम यूज़ करेंगे. ऐसे यहाँ पे होता है dz, dy, dx. तो सबसे पहले dz के रेस्पेक्ट में, देन dy के y के रेस्पेक्ट में, देन x के रेस्पेक्ट में. और लिमिट गिवन है, तो जिस वेरिएबल की लिमिट जो है वेरिएबल में गिवन के फॉर्म में गिवन है, उसके रिस्पेक्ट में आप पहले इंटीग्रेट करेंगे और दूसरे के फॉर्म में बाद में इंटीग्रेट करेंगे. So first we are here with double integral. Here integral is from 0 to under root of 1 plus x square, and integral 0 to 1. तो 0 to under root of 1 plus x square, इसका मतलब क्या है? This is limit of y. y is varying from y equal to 0 to under root of 1 plus x square. So here clearly y equal to fx varies from 0 to under root of 1 plus x square. So y equal to under root of 1 plus x square. It means y square will be 1 plus x square और ये आपके पास आ जाएगा y square minus x square equal to 1. Y square minus x square equal to 1. तो यानी ये हाइपरबोला का पार्ट हुआ. तो इस तरह से यहाँ पे डायग्राम के थ्रू भी आप ये देख सकते हैं. एंड हियर फ्रॉम इंटीग्रल we can see that we have to first integrate with respect to y keeping x as constant. तो इसको हमने ये सेपरेट कर लिया. इंटीग्रल 0 to under root of 1 plus x square 1 upon 1 plus x square plus y square dy and dx. पहले इस अंदर वाले पार्ट को हम इंटीग्रेट करेंगे और यहाँ पर 1 plus x square equal to a square पुट कर लिया. So finally we get this thing and this is tan inverse y by a multiplied by 1 by a. So now we put the limit of y from 0 to under root of 1 plus x square. So we have this thing tan inverse 0 is 0 and tan inverse 1 is pi by 4. So finally we get pi by 4 dx upon under root of 1 plus x square. And dx upon 1 plus x square, इसका इंटीग्रेट करेंगे. दिस इज log of x plus under root of 1 plus x square and limit is from 0 to 1. Now putting the limit, we get the required result. Next, there is one more example. Evaluate this integral dx dy over the triangle bounded by the lines x equal to 0, y equal to 0 and x plus y equal to 1. Now in this case directly आपको limit given नहीं है and you have to first find limit. Triangle bounded by the lines x equal to 0, y equal to 0 यानी x axis है y axis और x plus y equal to 1 आपकी ये line होगी that cuts the x axis at the point 1 0 and y axis at the point 0 1. तो यहाँ पर we have taken elementary strip parallel to y axis. So when we move this in strip from left to right to cover the entire area, we can see that in moving this strip from left to right, the x limit, the value of x varies from x equal to 0 to x equal to 1 and value of y varies from y. इस स्ट्रिप का जो एक एंड है लोअर एंड है दैट इज लाइंग ऑन द एक्स एक्सिस. तो ऑन एक्स एक्सिस y equal to 0 and other part is lying on the this straight line, and on this straight line we have x plus y equal to 1 or we have y equal to 1 minus x. So we can see here that x is varies from 0 to 1 and y varies from 0 to 1 minus x. So this becomes integral 0 to 1 minus x e की power 2x plus 3y dy. और जो x की लिमिट है x की वैल्यू 0 से 1 वेरी कर रही तो x की लिमिट आपकी 0 से 1 हो जाएगी. तो फर्स्ट वी इंटीग्रेट पार्शली विद रिस्पेक्ट टू y. e की पावर 2x एज इट इज रहेगा. e की पावर 3y को इंटीग्रेट किया तो e की पावर 3y मल्टीप्लाइड बाय 1 by 3. Now putting the limit, we get this thing. Now again integrating with respect to x, we get the value of this integral, and on putting the limit x equal to 0 to y, we get this value. The same way, there is a third example. Evaluate this integral over the area between the curve y equal to x square and y equal to x. Now y equal to x square is this parabola and y equal to x is this straight line. First, we find the point of intersection. We have, for the point of intersection, we equate these two equations. This gives x equal to 0 and y equal to 1. And if x equal to 0, we have y equal to 0. And for x equal to 1, we have y equal to 1. This means the curve intersect, these two curves intersect at the point 0, 0 and 1, 1. So these are 2 points of intersections, and we have to calculate the area between this parabola and this straight line. So here again we have taken a strip parallel to y-axis, and when we move this strip from left to right, then we can see here that x will vary from 0 to 1 and y will vary from y के लिए इस strip का जो lower part है, the lower part of this strip lies on the parabola y equal to x square and upper part lies on y equal to x. So the value of y varies from y equal to x square to y equal to x. So in this case, for the reason of integration, we have x lies between 0 to 1 and y lies between x square to x. We can also take here strip parallel to x-axis. Now when we take strip parallel to x-axis, तो strip जो है नीचे से ऊपर आप मूव कराएंगे, तो उस केस में y की वैल्यू 0 से 1 मूव करेगी और x की वैल्यू के करस्पॉन्डिंग जब पैरेलल टू एक्स एक्सिस मूव कराएंगे तो x की वैल्यू आपकी स्ट्रेट लाइन, इसका लेफ्ट पार्ट स्ट्रेट लाइन पे रहेगा और राइट पार्ट आपका कर्व पे रहेगा. इन दैट केस द वैल्यू ऑफ x विल वेरी फ्रॉम x इक्वल टू अंडर रूट ऑफ y to x इक्वल टू y. So we can take here, we can calculate the limit in both way. मतलब पैरेलल टू एक्स एक्सिस करके भी आप लिमिट कंसीडर कर सकते हैं और पैरेलल टू वाई एक्सिस करके भी लिमिट कंसीडर कर सकते हैं. जब आप पैरेलल टू वाई एक्सिस लिमिट पैरेलल टू वाई एक्सिस स्ट्रिप कंसीडर करते हैं, इन दैट केस वी गेट द वैल्यू ऑफ वाई इन टर्म्स ऑफ एक्स. और पैरेलल टू एक्स एक्सिस अगर स्ट्रिप कंसीडर करेंगे, इन दैट केस वी गेट द वैल्यू ऑफ एक्स इन टर्म्स ऑफ वाई. सो हियर वी हैव this integral, and clearly first we have to integrate with respect to y partially. तो with respect to y integrate किया, केवल y की terms को integrate करेंगे, x will remain constant. Now after integration, putting the limit x square to x, we get this integral. Now here we can see that all the terms are in all the variables are in x form. So now we can integrate this with respect to x, and finally we put the limit of this x equal to 0 to 1, and we get the value of this integral. इसी type से next example है. In next example we have to find the area bounded by the ellipse x square upon a square plus y square upon b square equal to 1. Now for the given ellipse we have the region of integration as this one, क्योंकि ellipse के case में we have this thing. और यहाँ पर when we take the strip parallel to here x varies from x equal to minus a to x equal to a, and when we take strip parallel to y axis, तो यहाँ पे आप देखिए इस फॉर्मूले के थ्रू y equal to, through this formula we have y equal to plus minus b under root of 1 minus x square upon a square. So the given ellipse is the curve bounded by these two values, y equal to minus b under root of 1 minus x square upon a square, and y equal to b under root of 1 minus x square upon a square, and finally x varies from minus a to a. So this integral takes this form, and here we have to integrate first with respect to y. तो जब फर्स्ट विद रिस्पेक्ट टू y इंटीग्रेट करेंगे तो इस केस में आप देखिए यहाँ पे लिमिट आपकी नेगेटिव माइनस ए टू एक फॉर्म की है, और इस केस में x इंटू वाई, वाई के रिस्पेक्ट में ये जो थर्ड पार्ट आ रहा है दिस इज ऑड फंक्शन, तो इसके करस्पॉन्डिंग आपकी वैल्यू 0 हो जाएगी, एंड इसके करस्पॉन्डिंग एक्स स्क्वायर और वाई स्क्वायर दीज आर इवन फंक्शन, तो इसकी करस्पॉन्डिंग वैल्यू आपकी डबल हो जाएगी. सो दिस इज ट्वाइस ऑफ इंटीग्रल 0 टू b अंडर रूट ऑफ 1 माइनस एक्स स्क्वायर अपॉन ए स्क्वायर. इसी टाइप से जब हम x के रेस्पेक्ट में देख रहे हैं तो x के रेस्पेक्ट में भी यहाँ पर ये इवन फंक्शन है, तो x के रेस्पेक्ट में ये जो माइनस a टू a लिमिट है ये आपकी हो जाएगी ट्वाइस ऑफ इंटीग्रल 0 टू a. सो फाइनली वी गेट 4 टाइम्स इंटीग्रल 0 टू a इंटीग्रल 0 टू दिस थिंग. इसको आप सिंपली विद रिस्पेक्ट टू y इंटीग्रेट करेंगे, यहाँ पर लिमिट पुट करेंगे, और इस लिमिट को सॉल्व करने के लिए वी आर टेकिंग x इक्वल टू a sin थीटा dx इज दिस वन, और इसको गामा फंक्शन फॉर्मूले से आप सॉल्व कर लेंगे. सो फाइनली वी गेट द वैल्यू ऑफ दिस इंटीग्रल. So in this way we can solve the questions corresponding to double integrals. So these are some questions for the assignment. You should complete this one. Thanks for the watching.